Okay, so the recording is in progress. Yeah, so we have, we were looking at this function swap that we were looking at it towards the end of the class. I want to emphasize the following, that the reason this function does not work the way we want is because variables are always passed by value in C. That is, whenever you are passing this x and y, a copy of this x and y is made in the formal variables for a and b, which are the named parameters for the function arguments for this function, and the a and b do get swapped. However, the actual x and y do not get swapped. So that is the reason why this swap program doesn't work the way we would have liked it to. So let us now uh, read another program that I have written and try to understand how it behaves, and we will see how this program works, and try to understand the behavior of different data types and functions. Okay.
In the previous program, ma'am, in the previous program, if we put the print statement inside the swap function, it would work normally, ma'am.
Okay, so but yeah, so what does it mean it would work normally? If what is your print statement?
No, ma'am, A and B, ma'am. Instead of X and Y, if we put A and B inside, print A and
So
B inside the...
this printf xy is printf ab here, right?
Yes, ma'am, yes, ma'am.
Yes. If you write that, then A will have the value 40 and B will have the value 20. However, what is our goal of the swap function? The goal of the swap function is the memory location which is given the name x should contain 40, and the memory location which is given y should contain 20 at the end of the swap function, or that is the goal of swap, right? And that is not happening. It is happening with this local variables a and b correctly. However, it is not happening with our variables x and y, which is the intention. Is that clear?
Yes, ma'am.
Yeah, sure. Okay, so there's another question. Will it work for x and y instead of a and b in the function definition? I did not understand, Satyajit. What is the question?
Right, x and like in that function definition itself, if we define integer x and integer y, then will it
Wait. So what is your idea? You are going to rename these parameters as x and y respectively. Is that what you are saying?
Yes, ma'am. Yes, ma'am.
Okay. So the proposal that Satyajit has is that you are going to, instead of calling these formal parameters as a and b, call them x and y. Does it make a difference? Can somebody answer? Please answer it in the chat. Okay, there is no difference that happens if you do this. And just to make sure, this is a very, very simple program, but just to make sure that we all understand what it means and why this thought can come to mind, let us just go, and I am going to show you this execution of this code in a slightly different environment than our REPL environment, but it will allow us to see how the memory is organized when you are running these programs, and it will also allow us to talk about the place where the memory is allocated, the way memory is allocated and where it gets allocated. So I'm going to share a slightly different thing. Okay, so just give me a moment. So Kaushal, you are able to see my okay, not yet. Browser, is it right? Okay, good.
Yeah, yes.
So I want to go to REPL and then copy this swap program. Yeah, not this one, the swap program. So this is the same swap program that we have written in the slide. I just want to copy this swap program. I don't want to run it here. I want to run it in a slightly different environment. So I'll also share this environment with you. It is a very nice tool which allows us to visualize programs. Okay, so this is the same program. I have chosen this GCC compiler, and now there is this visualize execution. So, so Kaushal, is it visible, and is it visible in a correct, good font in the sense you can read it?
Yes, ma'am.
Okay, great. So as everybody can see, there are these two things that it is showing out. So it is showing on the right hand side, there is a stack and there is a heap. So everything that we are doing at the moment is something which is on the stack. So whenever there is a function call, this is the function which is main, which is currently active. There is exactly one function which is active at any point of time, and the corresponding local variables of that function are allocated on the stack. And because the current line or the next line to be executed is this, it is only that there is x and y which are variables for which there is memory, but they have not been initialized. That is why that is question mark is shown here, right? So now if I do next, it is going to run this next line, which is int x is equal to 20, and it will initialize that variable x. Now when I say int y is equal to 40, it will initialize this y. And when I call this function swap, there is a new function call which is going to get invoked, which will create its own local space for this swap, which will be shown here. So now the currently active function is this swap, and this is the one which has this local variables a, b, and temp, which are shown here. So just to answer the question, whoever said this, even if I would have named these variables x and y, it is still that these x and y which are local to swap will get swapped correctly. However, these main x and y, the variables x and y here, will not get swapped. So let's just complete the execution. So temp is, so x and y are so when I've called this, it has copied to x the whatever is the value of a, it has copied to y whatever is the value of copied to b whatever is the value of y, and it is now executing temp is equal to, it is now going to execute temp is equal to a. And oh, so sorry, what has happened? I think I changed something. I'm very sorry. Okay, so yeah, just give me a minute. I don't know why it is doing it this way. Okay, I think this line is for some reason highlighted. Just give me a minute. Yeah, so let's visualize the execution once again. I think I touched it by mistake, and that is why this has happened. Okay, so just to show it to you again, we have seen the first few steps, and now if you do temp is equal to a, then temp has got correctly assigned the value of a is equal to b, which assigns the value of b to a. This is done, and after this, all of this whole stack that is there, I mean, whatever is this frame for swap is going to get erased. It is no longer available, and therefore whatever was done here is lost, and x and y remain unchanged, and therefore this is the same story for x and y. It remains as it is, and therefore when we print out x and y, whatever was 20 and 40 will just get printed out. So I hope it answers and illustrates what is happening when the program is getting executed. I also want to show you that, I mean, as we invoke more and more functions, this stack will keep growing, and it is going to grow down in the sense that it will keep growing down, and the topmost one on the stack. So a stack is a data structure that behaves in something which says it is last in, first out. That is whatever was the one which was put last, that is swap which was put the last, is going to get out first, and so on. So there are several things, several real life examples of stacks and so on. Okay, so any questions on this simple program or this execution? Okay, so I'll go back to the slides and let's look at the second program that I want to show you. I think my slides are not visible. Yeah. Okay, so I want you to read this program, and all of you, I want to tell me what are the printf statements executed. What is the output of the printf statements? There are two printf statements, so there are two outputs or two things that are printed by this program. So I want you to tell me what are the two things that get printed out. Please write down your messages in the chat window so that I can see what you write down. So you can just write it as comma separated, because I know if you put in an enter, then 2 times it comes in. So just put a comma and say what gets printed out in replace and what gets printed out in main. Okay, so clearly one answer is not correct, because you have to write down two answers, one which is printed out in the replace, the second which is printed out in main. And I'm assuming that you will write the first which is printed out in replace. Okay, so all of you at least see that whenever we are sending this string, character string to this replace is taking replace is looking at all the string as long as it does not see a /0, and then whenever it sees a little s, it is going to replace it with capital S, and if it does not have a little s, it doesn't do anything with that string. So this is the function. It is going to just replace the little s if it is present by a capital S. So now what we are asking is, what does it print here versus what does it print here? And many of you have written the answer correctly. That is, it will print out math capital S in replace, which is of course correct because it has replaced S of I by the capital S. Now, many of you have also written that it will print out math capital S in main. Some of you have written that it will print out math little s in main. So now let's understand the behavior of this program. So we have already seen what is the output of the program. You have given it out. Now, but we have already said that variables are passed by value in C always. So every variable that is passed by value in C. So similarly, array is also passed by value in C. So then how do you explain the fact that some of you who are saying that math S is being printed, capital S is being printed in both replace as well as in main? So can somebody unmute and tell me?
ARR is a pointer, so address of the ARR will be passed.
Okay, so what we are saying is that this is still true. We are not passing anything by reference. There is a pass by reference mechanism which is supported by some languages. It is not supported by C. Everything that is passed in C is passed by value. However, if you recall, we had done this printf %p array, which is saying that print this, because this array is itself a pointer. It means that it is pointing to the first location of this large memory cell that we have, the 10 sized character array that you have, and it is ARR is pointing to the first location, which we are saying is ARR of 0. And if you print out %p and of array, it is the same thing. So both of these are pointing to the same thing. So in fact, it is the address of this memory, the 10-celled array that you have, and that is what is ARR. So ARR gets copied. So it is not that anything is being passed by reference. This address gets copied. However, because this address gets copied when this function is called, when you access it here, that is when you are saying S of I, it is so S of I internally saying take this base address and then go to this offset I. So this depends on whatever is the type of this character, type of this array. In this case, it is the character array. So it will say that go by so many bytes into I, because each character is just 1 byte. And then you are going to say that, okay, I am 1 byte into so much offset into the array. So whenever if I is equal to 10, then you are going to say that go 10 bytes away from the base. If it is 2, then you are going to say 2 bytes away from the base, and so on. Now, therefore, as long as you are passing an array, the array address is getting copied, and therefore whenever you say S of I is equal to capital S, that memory address is array location is accessed, and in that, instead of little s, capital S is copied. This is happening wherever that array is allocated, and that array was allocated in main. Therefore, it is that array is going to get changed. So this is something that I want you to remember, and therefore this, because the way arrays are in C, that is ARR actually means that it is the address of the array variable. Passing this array to a function behaves like a pass by reference, which is supported by other languages like Pascal or C++. However, everything in C is pass by value. So this, I hope it explains to others who wrote that it will print out math S, capital S here and small s here, that this is not something that is going to happen. So just for illustration, we are also going to see this running in our new this thing where you can see it in action. So I'm just going to show it to you once again. Before that, are there any questions? Okay, so I'm going to now show you this in the yeah. Okay, so Kaushal, just tell me whether my browser is visible to you. Just give me a moment. Yeah, is it visible now?
Yes, ma'am.
Okay, so I hope everybody can see the program, which is the same program that you have already observed. And let's look at the execution. So it's very instructive to see the execution, although most of you understand it. It will be helpful for everybody else in the class. Okay, so first and most importantly, this ARR is the array that has been character array, and all these memory locations are given contiguous spaces in this stack where it is located, and these are uninitialized to begin with. Now, when you run this code, it is going to initialize it using this maths, and you can see that happening. And the at index 5 and onwards, it is initializing it to 0 the way we had said it. It will get initialized to /0, which is having the ASCII code as 0. When you call this replace, the current active function is replace, and it has its local variables S, which is a character array, which it knows that it is a pointer, and its local variable, of course, I, which has not yet been initialized. As soon as this call is active, it points to this array location, which is the array in the main. And that is why it is going to be changing things when we are changing it there. Now, of course, it is clear. Yeah, I is going to run from 0 all the way up to 4, actually 5 when it sees the first this thing. But the interesting part happens when it is actually seeing it for 4. So I am doing this execution a little fast, but I hope you see that when it is 3, there is nothing to do. When it is 4, it indeed is s of I is equal to little s, and therefore it changes it to capital S. As you can see here, it has been changed, and this is the array is not copied locally into the function, just the unlike the way the variables x and y were copied, and that is why this is the array which is getting changed, which is the same array that was there in main, and that is why this array gets modified even when we are passing it to this function. It is not locally changed, but it is changed for the caller as well. And then it returns. And finally, when you print it out, of course, you can also see the printf statements here, I think. So you should be able to see the printout. So the print is from, first is from the replace. The second one is from the main. And of course, both of them are referring to the same array. So therefore, there's nothing different that they can print out. Okay, so this is what I wanted to show you. Any questions on this part? Okay, so I have a few questions. So I would like, okay, so yeah, so I would like you to tell me a few things. For example, okay, so okay, tell me, Kaushal, what is visible right now? This the not the slides, but the browser, right?
Yes, ma'am.
Okay, sure. So I would like you to tell me the following. So for example, is it possible for me to say that can I leave this empty, and can I say char of s in with the square braces but with no number? Can I define a function like this? Is it possible in C? Will this
Yes,
code
ma'am.
compile is the question. Okay, so you are saying yes. Okay, so the second question that I have is, let's say that there was a function. I'm just going to use this function only. Suppose there was a function which is taking a matrix. Let's call it an integer matrix M. So the actual one was matrix something like 2, 4. So can I change this to void int matrix? Can I say this, and is this also a valid thing? Just like what you have done with this replace, I had this earlier 10. Now I have changed this matrix to tell the compiler that it is a 2-dimensional integer matrix, but I leave the dimensions unspecified.
I think we need to specify the columns, like how many columns does a matrix contain.
Okay, so Kaushal,
Like
you are
for this.
speaking.
Oh yeah, I thought you were saying to answer. Okay, sorry, my bad.
No, Kaushal. No, of course not. Yeah. So, sure. I mean, I know that you know the answer. Okay. So, yeah. So I want the students to answer, and the students are also saying the same thing that Kaushal is saying. So, I would like the students to tell me why they are saying that the column should be specified.
This is Sri Lakshmi.
Yes.
So, ma'am, even if it's a two-dimensional matrix, it's the data is stored in a one-dimensional sort of way. So then the compiler needs to know when one row gets over and the other row begins, right? So then we need to at least mention the number of columns. Even if we don't mention the number of rows, it's fine, but at least the number of columns we should mention.
Okay, so does everybody see the explanation that Sri Lakshmi has mentioned? So what Sri Lakshmi has mentioned is, suppose you are interested in sending a matrix to a function, then you can leave the first dimension of the matrix unspecified. However, you still need to tell what is the second dimension of the matrix. in general, if it is a k-dimensional array, we'll just call it a k-dimensional array, you can leave the first dimension unspecified. However, you must specify all other dimensions for the compiler to calculate the addresses of the memory cells that it has to access. So this is something which is important, because as we have said, the memory is flat. So if even if I define so let me just comment out this, which is not code which will compile, but let us just define a matrix which is here, which is int m23. We know that while it is a two-dimensional matrix for us, when it is given space in memory, it is given space in a linear way. So again, it is showing us this in this way for us to understand that this is a two-dimensional matrix. However, this is just a flat thing which is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. So this is a flat thing that is given to us. The visualizer is too intelligent because it is showing us it in a matrix form. So when you pass it to some function, the function needs to know that if you tell it to go to some row ij, it needs to calculate how many cells should it skip before it hits the row I. And for that, it needs to know the column numbers of the matrix, and that is sufficient. So now the question is, what about the rows? What if you access something which is incorrect in terms of the rows? So for example, if I leave this unspecified, and this is a character array of size 10, and if I access something which is like 15 in this character array, what happens? Or even just if it is a character array of size 10, I should not access anything with 10 or larger. So if I access s of 10, what happens, and how does it handle that? Can somebody answer this? So you have told me that this first dimension can be left unspecified, which is correct. Now I want you to tell me what happens when you access this, or how does it handle when I access the 10th element of this array? Okay, so somebody has asked me to repeat the question. So I'm saying that let's go back to this this code which you are able to see here, where I have said replace of char s with the empty square braces. So I have not said what is the size of the array. Let us say that I just access, instead of saying while s of I is not equal to 0, I just say for I is equal to 1 to 20. I believe that this is a 20 sized character array. And I just say for I is equal to 1 to 20 or 0 to 19 or something, do something in maybe the same thing if I say, then what happens? Or how does the compiler take care of this? Okay. Okay. So I have two answers from two people, but what about others?
Ma'am,
Yes.
I have a doubt, ma'am. Like here, we didn't specify it, ma'am, but the value is already stored in this variable only, ma'am.
I didn't understand. So where is the value stored? Sorry.
Like no, ma'am, we will be entering the string value, no, ma'am, to s.
We'll be entering what value?
No, ma'am. For this function to work, we need to give it some word, no, ma'am. So to work on.
We need to give it
So-
some character array or string. That's what you're saying.
Yes, ma'am. So it will already be
Okay.
stored in it. So accessing it won't be a.
Yeah, but what I'm saying is okay. Can you mute yourself, Kandikeshwar? Okay. So what I'm saying is this is a valid C function definition. That is, you are saying that void replace char s just without the size of the array is a valid C function. C this thing. So we are not saying what is the size of this array. So instead of writing this loop which is running from running till s of I is not equal to 0, I'm saying suppose I had run a for loop which runs from 0 to 19, assuming that it is a 20 sized array, what would happen? but I am passing it a 10 sized array because now there is no check. It cannot check, right, whether I am sending a 10 sized array or not, because I am not saying what is the size of the array. Is the question clear, Kannikeshwar?
Yes, ma'am. Yes, ma'am.
Yeah. Okay. So whenever we are saying that it is S with the square brackets, the compiler is only checking that you are sending an array which is of the appropriate type. As long as you send any character array of any size, the compiler is fine with that, and it will just it will just let the function take care of accessing it. If you access more than what is there in the array, it will give a sec fault, as some of you have written. So accessing valid elements of the array is something that is the responsibility of the programmer. It is not the responsibility of the compiler to make sure that you are accessing valid elements of the array. It is the responsibility of it is our responsibility that we write code which accesses valid elements of the array and does not go beyond the ranges of the valid indices. So we cannot rely on the compiler to take care of that. In particular, if you write this replace function like this, you can send any size character array and your function should be taking care of it. So in most of the cases, you are going to also send the size of the array. In this case, it is not required because character arrays are typically strings and they are terminated by a /0, so it's okay. But if it is not a character array, an integer array, then it is typical for you to send the size of the array and then run a loop from I is equal to 1 to n, which is the size of the array. So this is something that you have to remember. So while the compiler asks for the second and third and fourth parameter, if there are more dimensions to the array, it is not responsible for taking care that your program is accessing valid elements. It is only to calculate the offsets that it is taking this. It is not responsible to take care of the valid memory accesses. So this is what I wanted to illustrate. Okay, so are there any questions here?
Ma'am?
Yes.
So if it's an integer array, then we should always specify the value. I mean the value of the index, ma'am.
Size.
The size of the array. Yes. Yes.
Yes,
So,
otherwise there is no way of knowing unless it is a particular array which is terminated by a certain thing which the function is aware of. You won't know how much to access. So typically for integer arrays, you are going to specify the size or the low and high indices of the array in which you want to operate, something like that. Right? Okay. So having done this any other questions? Okay, so having done this, let us try to do one small exercise, which we will do on REPL.it, and in which we will okay. So in which we are going to write a function, in fact, we are going to modularize the selection sort that we have written, and you people are going to help me do that. So what we want to do is we want to write the selection sort, but we don't want to write it as a main function, and we want to modularize it, and you are going to help me do that. So we are going to do it together, right? So let me just create a function, create a file first. So I'm going to call it so again, Kaushal, can you tell me whether it is visible, REPL.it? Okay, so this is the function which is mysort, not function, this is the file which is mysort.c, and okay, I'm sorry, I didn't go to this functions. Yeah, Okay, so this is a fresh file that we have written. I'm going to write a, okay, so let's start with, so I'm going to define an integer array A, which is of size 10, and just initialize it with some arbitrary values which are unsorted. So, and we'll do the same way that we had done, that is we are going to sort it in decreasing order. So I hope there are 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So these are 10 values. I would like you to tell me how would you think of modularizing the selection sort? What would be the smaller subparts? Yeah. So what should I do in the for loop, which I can write as smaller functions? So is everybody with me? That is, we are interested in writing selection sort. Selection sort is a sorting procedure which will sort this array in, let's say, non-increasing order. That is, the maximum will be at the first position, that is 0th position. So following that, the second maximum, and so on. And the minimum will be at the position 9. So this is how you want to sort the array. What would be the smaller subparts that you can write down? So what is it that you want to do in every iteration? Okay, find and return the maximum. Okay. Okay, so I'll just okay, so there are answers which say, so please do not say that if A of I is greater than, we don't want to do that in that is not how modular code is written. So of course we know how to write selection sort in the main program. We want to modularize it, make it into smaller parts. So what is the function that you would want to use, or what would be a function which is useful? Okay, so somebody is saying return the max and its position. So we have not seen functions which can return two values. So how would your function return two values, and are two values needed? Okay, so just after a little thought, we realized that the max value is not needed, but the max index is needed. So now if you need the max index, okay, so we need the max index, but we need the max index for what part of the array? So I want you to tell me what is the prototype of the function which would be useful for this. So what should be the input to that function, and what should be the output? Everybody agrees that the output should be the max index, but max index where? Into the array or where? So it should return the max index from what to what index, and therefore what should be the parameters of the function? Yeah, can some of you unmute and tell me so that we can write it together? Okay, so int max index null will not work, right? Because if you write int max index null, then that function does not know which array to work with between what indices of the array. Because if you don't tell the function with what indices to work with, the function is going to work always with the whole array. And every time if you get the maximum in the whole array, that is quite wasteful. So please tell me what kind of a function will be helpful. Okay, so Nanda Gopal, you have said int val int array. So what does val represent for you?
The val represents the value of I that we are currently at. So we send back the value of I, and the entire array we start from the next
Just
value
hold
of,
on. Yeah, so are you making an assumption that the array index, the last index of the array is 10 or something?
yes, ma'am. Oh, okay, yeah. I made an
Because
assumption
otherwise
like
I
that
don't know
because we
where
have
to end
fields.
my this thing, right? So
Yes, yes, we have to
good. So
consider.
I think, I hope that this illustrates what should be the prototype of the function. So let's write the prototype. Int max index, int a, I'll use a different parameter so that it doesn't confuse you. So int b, as we have said, there is no need to say 10 because we can in fact pass any sized array to it as long as it is an integer array. And I'm going to say int low, which is the lower end of the array from which you want to start accessing it, and int high, which is the higher end of the array where you want to stop, both high and low. So when we write such a function, it's good for us to write to ourselves that this function returns an index which denotes the maximum element in B from in the set B of low B of high, both inclusive, right? So both of these are included. So it returns an index which denotes the max index, not max index, which denotes the index of the element in B of the index of the element, sorry, index of the index of the max element in B. In B in the set B low to B high. So in this range, it is going to give us the max index, right? And it is not going to return us the maximum value. It is going to return us the index of the element into this, right? So this is what it is going to do. It is going to return us the index, which denotes the index of the max element in the set B low to B high. Okay, so is this okay? I mean, this comment could have been written slightly better, but I hope this is understandable to all of us. So if you have this, then let's not even get into writing that function. But then what should you do? You should just say max index is equal to, sorry, some variable int k is equal to max index of a I, and always it is going to be 9 because you want to access from I to, I mean, whatever is that I up to 9. So let's say you have found out this. Now what should you do? So let's say this max index is appropriately implemented. After this, what should you do? So are students there or they have left? Okay, I think a lot of students are there. Okay. So now you are saying that swap A of I and A of K. That is correct. Now suppose I just for the sake of this thing, I want to use a function. Remember that we cannot write the function. I mean, we cannot write a function to swap integers. So what can we do? I mean, what kind of a function can you write such that the swap will be done correctly? You can of course write 3 lines of code where you are going to say that temp is equal to a of I, then a of k is equal to temp and so on. But I just am forbidding you from writing it. Again, just to illustrate the point, but how would you call a function? What can be the parameters to the function such that the function really swaps the values at I and k? Okay, so some of you have the correct idea. Okay, swap function, but take array Yeah, so as of now, addresses are not allowed because we don't know how to write the actual prototype for the function, which will require pointers. So Arjun, I'm forbidding you to say and of a and so on. Okay, so already we have seen that we can, I know that students know that how to use pointers, but I'm not going to use pointers to begin with here because we don't know how to write pointers. At least we have not studied in the class. So that's why what we are going to do is we are going to write a swap array function which does the following, that it is going to take an array as a parameter, which is a, and the two indices into the array which need to be swapped. So in this case, the index is I and k that we have identified, and the prototype of the function is the following. It does not return anything. It does swap into the array. It takes an array, again we'll call it B, doesn't matter what you call it. It takes two indices, I'll just call them index 1 and index 2. Again, please see that we should name the parameters correctly. So these are indices into the array, and what it does is the following, that is, it swaps the elements at index 1 and index 2. And this we already know how to do. That is, you can write, you can use the temp variable and do the same. That is, you know how to write these 3 lines of code, or you can do it without the temporary variable. But once you do this, your code has become very modular. Now you have this swap A. This is working because this array is something for which you have copied the address and sent to it. So whenever it is accessing this array element, it is going to access the same array A that was defined in the main, and that is why that array will get swapped. The locations will get swapped appropriately, and therefore your max will actually go to its correct position, and the element which is present at the max position will go to this. So this is how you are going to modularize your selection sort. Although we did this same thing, I had written this earlier, the selection sort as a small function. I think it is somewhere outside. I'll just show this to you, and yeah, so this is the function which I had written, which is almost the same, but maybe the naming of this thing is slightly different. So, and the array of course is different. So if you see this, there is some array which is of size 10. I'm running a loop from I is equal to 0 to I less than 10. M index is get max index array of array, and then I and 9. And then swap A, the array is passed, index 1 and index 2 are passed, and here the naming is slightly worse. It is called I and J, but you could call it index 1 and index 2 and swap them. So if you run this program, this will work the same, exactly the same selection sort that we have implemented earlier, except that it is modularized. And note that we have crucially used the fact that arrays are addresses. Therefore, when they are passed to functions, modifications to the arrays in the functions are reflected in the caller as well. So this is all I wanted to say. Any questions about this part? The interesting part is, of course, in the get max index, which is this max index. But remember that this is a modular function which will allow anybody else to use this function, where you can pass it an array and the suitable indices into the array where you want to find the maximum index, and this will always return that max index. We don't need the max value. That is why this max index is sufficient. Okay, so if there are no more questions, I am going to stop the recording.